Today we are going to discuss about the chapter work and energy. In this chapter, we'll be discussing about work, energy and power, different types of energies and power. But in this video, we are only discussing the main points which are useful for you for the examination. So in this video, we will be discussing about work, different types of work and the power. Okay, let's go to the introduction of work. That is, work done on an object is defined as the product of the magnitude of the force acting on the body and the displacement in the direction of the force. Yes, we have already studied that work done is equal to product of force and displacement. So these two criteria are very important, force and displacement, isn't it? Work is equal to force and displacement. So if we are applying a force to any of the objects, and if the object moves to a certain distance, then only we can tell that work is done. Okay, work is said to be done only when the body undergoes displacement in the direction of force. So displacement should be there, and at the same time force should be applied. These two are very important, then only we can tell that work is done. Now SI unit of work is joule. So here we are deriving this formula, that is 1 Newton. W, work, is equal to force into displacement, and 1 joule is equal to, what is the unit of force? 1 Newton, and unit of displacement, or what we call the meter. So in this way it has become 1 Newton meter. So 1 joule can be written as 1 Newton meter, because work is equal to force into displacement. Newton, N stands for Newton. Newton is the unit, SI unit of force, and meter is the SI unit of distance or displacement. So 1 joule becomes 1 Newton meter. So let's define 1 joule. Okay, so work, what is work, what is the formula to find out the work, and SI unit. We have discussed all these things. Now we are going to define 1 joule. How can we define 1 joule? Yes, it is the work said to be 1 joule when 1 Newton of force acts on a body and causes displacement of 1 meter in its direction, in its own direction. That is, work is said to be 1 joule. We can tell that 1 joule work is done when we are applying 1 Newton force and the body has displaced through a distance of 1 meter. Okay, it is very simple. Just remember this formula, then you can write the definition of 1 joule. 1 joule. When we will be telling 1 joule, when work is said to be 1 joule, work done is 1 joule. When 1 Newton of force is applied on any of object and the object has got a displacement of 1 meter. Okay. Next we are going to learn about types of work. So when we talk about the work, there are 3 different types of work: positive work, negative work, and zero work also. Okay, what is positive work? Positive work, when force applied causes displacement of body in its own direction. Yes, that direction is very important. You can just look at this picture here. F stands for the force that is applied. It is applied to this direction, and the body is also moved to a certain distance d in the same direction. Both are happening in the same direction. F is applying in this direction and it has got a displacement in the same direction. What is the displacement? D. So here both are having, or both are moving to the same direction, both are happening in the same direction, so we can tell that it is a positive work. Okay, now another example, pushing. Yes, pushing the door. Once we push the door, we are applying a force on the door, and in the same direction if the door moves, then we can tell that it is positive work. And kicking football, that is another example. When you are kicking a football, you are applying the force on the ball. In the same direction, the ball is moving. So here also positive work is done. So we can cite a lot of examples from your daily life for positive work. Next one, negative work. When applied force causes displacement of body in its opposite direction. How it happens? When we are applying a force and the body is moving in the opposite direction. At that time we can call it negative work. Just think about the friction. See, here we are going to push a box which is blue in color, and in the green color we are having the surface. Okay, this is the box and this is the surface. Surface is in green color. Okay, this is the surface which is in green color, and this is the box which we are going to push. Okay, here the direction of the force is already given. It is indicated by red arrow mark. This is the direction of the pushing force. And the motion is again indicated by another arrow mark. You can see motion in, so the box is moving in the same direction in which the force is applied. But you can see another force is there. This one, frictional force. We have already studied about friction in 8th standard in detail. Friction opposes motion. That is the most important thing that we studied about friction, isn't it? Friction opposes motion. It acts between two surfaces in contact and it opposes. It tries to slow down the motion, or it tries to stop the motion. So actually whatever may be, whether it is slowing down the motion or it stops the motion, actually what is happening, it opposes the motion. It is acting just opposite direction, isn't it? It is acting in opposite to the pushing force or the motion of the object. In which direction the body is moving, in just opposite direction the frictional force will be acting. So frictional force is applying a force, isn't it? Friction, the surface is applying a force, that is known as friction, on the box, but the box is moving in this direction, opposite direction. See, you can understand the difference in their direction. The motion, the movement is in this direction and the frictional force is acting in the opposite direction. So the work done by this frictional force, that is negative work. You got the point? Negative work. Friction is applied in this direction and the body is moving in the opposite direction. So in this context we can tell that the work is negative work. So positive work means force and motion are in the same direction. Negative work means force and motion of the object are in the opposite directions. I hope you understood all these things. Now zero work. The third one is zero work. It is done when force acts at a right angle to the direction of the displacement. Or one more criteria is there, if there is no displacement. So let's discuss about there is no displacement. See this, these two figures, the blue box and this person trying to push the wall. You can see in both these contexts there is no movement. He is trying to push the wall. This person is trying to push the ball, but the wall is not moving, isn't it? In this picture the person is trying to move the ball, but it is not moving. Here also same thing, this boy is trying to push this stone, but he is not able to push it. He can't, isn't it? But in this what he is doing work, yes or no? But since there is no movement, no displacement, we cannot consider it as a work. No work is done by him. It is zero work, because we know that work W is equal to force into displacement, isn't it? Work W is equal to force into displacement. Here force is applied by the body, isn't it? The boy is applying force, but what happens to the distance moved by the object? That is zero. Yes, zero movement, that means work is zero. Here also the same thing. Now let's discuss about this potter carrying weight on top of his head. This person is carrying a certain amount of weight on his head. So what is the direction? Here it is clearly indicated by the arrow mark. Force is applied in this direction and the displacement is just perpendicular, isn't it? These two lines are perpendicular to each other. So what happens is that force is acting in this direction and the displacement is acting in this direction. So when the angle between these two is 90 degree, this again the resultant work will be 0. Okay, the resultant work will be 0 at that time. So about this you will be studying in detail in the that is next coming years. That is work done is equal to FD cos theta. Then when angle is the angle means the theta is 90 degree, what happens is that will become 0. Cos 90 is equal to 0. So the again the resultant effect will be 0. Okay, so don't worry about that. Please understand this is force applied and displacement. Both are perpendicular to each other. Then the angle between them is 90 degree. Here you can see that the force is applied in this direction and the displacement in this direction. So that they are perpendicular, both are perpendicular, and in this context also the work done will be 0. So this is very, very important. Always this kind of questions comes for the examination. What kind of work is done by the potter while he is carrying a load on his head. I hope you understood. So the next one we have just write down all the important points, that is force and displacement. If both force and displacement are perpendicular to each other, work done will be 0. And if force and displacement in the same direction, you can see the head of the arrow, they are indicating same direction, so work done is positive. If force and displacement are in opposite direction, see one arrow mark is indicating towards this direction and the other one is towards this direction, so both are in opposite direction, so the work done is negative. Okay, now let's discuss about power. What is power? Power is defined as the rate of doing work. Rate means what? Something is divided by t, that we call rate, isn't it? Something is happening in a particular time, then we call it the rate. So here power is the rate of what? Rate of doing work. Work divided by time, that is how much work is done in a particular unit of time, that is known as power. Power is a scalar quantity because it does not have any direction. It's a scalar quantity, and unit is what? 1 watt is equal to 1 joule per second. It's very easy to derive this expression. 1 watt is equal to 1 joule per second because power P is equal to, we can use this formula, that is power P is equal to W divided by T. Work, we have learned that work is equal to Newton meter, or the unit of work is equal to joule, isn't it? In both the way we can apply this, divided by T. T means seconds. The unit of time is equal to second. Here also divided by second. So that is equal to Newton meter per second or joule per second. In both the way you can write, both are equal. Newton meter per second or joule per second is the unit, that is 1 watt. 1 watt is equal to 1 joule per second or 1 Newton per meter per second. Power is said to be 1 watt when 1 joule. Now we are going to define 1 watt. 1 watt is equal to when 1 joule of work is done in 1 second. That is 1 joule divided by 1 second. That is equal to 1 watt. How we can define? That is when a joule of work is done in 1 second, then the power is said to be 1 watt. So older unit is horsepower. That is very, very important. This is the older unit. 1 horsepower is equal to 746 watts. This question always comes for competitive examination and all. What is the, or which is the older unit of power? That is horsepower, and 746 watts is equal to 1 horsepower, isn't it? That means traditionally we consider horse as a strong animal, isn't it? Horsepower, like that the horsepower game. You must have seen your home electricity bill, and the bill that we get is like 45 units, 100 units, so on. All are familiar with that. When you get the electricity bill, it might have written 45 unit or 60 unit you spent. You consume this much of unit. So that unit means what? Actually kilowatt hour. The unit that we are talking about in the electrical energy and all, that unit is actually 1 unit. 1 unit means 1 kilowatt hour. If you have any doubt, take out the electricity bill and check for it. 1 unit is equal to 1 kilowatt hour. And we can also relate kilowatt hour with joules as follows. So we are going to convert this into joule. 1 kilowatt hour is equal to 1 unit of electricity, and this 1 kilowatt hour is equal to 3.6 joules. So this is also important. 1 kilowatt hour is equal to 3.6 joules. And based on this watt, this kilowatt hour, so how many mathematical questions will be coming. So we will be doing all these things. See, here we can find out the powerfuls. This is your task. You will have to find out the power. Okay, and write the answer in the comment box. That is, when you apply 12 Newton force, the displacement happened to the